Hello, welcome to Astronautics for Exploits. This is Dr. Ayoshola Ogundele. Lunar South Pole, a priceless region for future space exploration and lunar outpost. The focus points are as follows: Lunar South Pole, Lunar South Pole resources, Lunar South Pole geography, and lunar future space exploration and lunar outpost. Over the years, humans have been curious to inhabit the moon. What was initially science fiction is gradually becoming a reality, where humans will be vacationing on the moon, living and working, conduct state-of-the-art research, and extract abundant natural resources abound on the moon for the benefit of humanity. Out of the regions of the moon, the lunar South Pole, the southernmost point on the moon that is located on the center of the polar Antarctic Circle, and that is 80 degrees south to 90 degrees south, is receiving high interest from the scientists, government space agencies, and private space companies due to the possibility of the occurrence of water ice in permanently shadowed area around the lunar South Polar region. According to the research findings, the lunar South Pole regions have well-protected craters whose interiors are not reached by the sunlight. This feature made it to be unique. Dated back to the early solar system, the craters are found to contain water ice, hydrogen, volatiles, and a host of others. The lunar South Pole has mountains and basins, such as the south side of Malapart Mountain, that do not face Earth and will be an ideal place to receive astronomical radio signals from a ground radio observatory. It is a place where scientists can perform unique astronomical observations of radio waves under 30 MHz. Various government space agencies have explored the lunar South Polar region, are exploring it, and are also planning to explore it in the future. Examples of some of the spacecraft that are explored the region are Lunar Orbitus, Clementine, Lunar Prospector, Lunar Reconnaissance Orbiter, Kaguya, Chandrayaan-1, and Aircross. Lunar South Pole. The lunar South Pole is the southernmost point on the moon. It's of great interest to space agencies and companies for exploration because of the occurrence of water ice in permanently shadowed areas around the region. Illustration of the lunar South Pole at the center of the image is shown in this picture. The lunar South Pole region features craters that are unique because the near constant sunlight does not reach their interior. Lunar craters are cold traps that contain a fossil record of hydrogen, water ice, and other volatiles dating from the early solar system. In contrast, the lunar North Pole region exhibits a much lower quantity of similarly setted craters. Full moon with South Polar region features is shown in this picture. Lunar South Pole resources. Research findings show that lunar surface contains elements such as hydrogen, oxygen, silicon, iron, magnesium, calcium, aluminum, manganese, and titanium. Among the more abundant are oxygen, iron, and silicon. The oxygen content is estimated at 45%. The lunar South Pole contains abundant natural resources such as solar power, oxygen, and metals. Visualization of circuiting crater with lunar South Pole visible as the tiniest illuminated rim of the Earth visible large circuiting crater is shown in this picture. The lunar South Pole features a region with crater rims exposed to near constant solar illumination, with the interior of the craters being permanently shaded from sunlight. The lunar South Pole illumination was studied using high-resolution digital models produced from data by the Lunar Reconnaissance Orbiter. Illustration of NASA's Orion spacecraft planned to take astronauts from Earth to the moon and return them back as part of the Artemis mission is shown in this picture. Findings show that cold traps are some of the important places on the lunar South Pole region for possible water ice and other volatile deposits. Cold traps can contain water and ice that were originally from comets, meteorites, and solar wind-induced ion reduction. From experiments and sample readings, scientists were able to confirm that cold traps do contain ice. NASA's lunar trailblazer is shown in this picture. Lunar South Pole resources, hydroxy, was found in the cold traps. The discovery of the ice and hydroxy compounds has led to the funding of missions focusing primarily on the lunar poles using global-scale infrared detection. The ice stays in cold traps because of the thermal behavior of the moon that are controlled by thermophysical properties, such as scattered sunlight, thermal radiation, internal heat, and light given off by the Earth. Artist rendering of the Lunar Crater Observation and Sensing Satellite is shown in this picture. Lunar South Pole geography. The lunar South Pole is located on the center of the polar Antarctic Circle of 80 degrees south to 90 degrees south. The axis spin is about 88.5 degrees from the plane of the ecliptic. The lunar South Pole has shifted 5 degrees from its original position billions of years ago. Artist's illustration of intuitive Marcin's Novosil lunar lander on the moon is shown in this picture. The shift in lunar South Pole changed the rotational axis of the moon, allowing sunlight to reach previously shadowed areas. In addition, the South Pole features some completely shadowed areas. Lunar South Pole also contains areas with permanent exposure to sunlight. It features many craters and basins, such as the South Pole Aitken Basin, one of the most fundamental features of the moon. Chinese 6 mission is shown in this picture. Lunar South Pole temperature averages at approximately 260 Kelvin. The lunar South Pole, defined by the rotational axis of the moon, lies within the Shackleton crater. Notable craters nearest to the lunar South Pole include the Galaxy, Sverdrup, Shoemaker, Faustini, Howard, Nobel, and Cabeus. Artemis 1 mission trajectory is shown in this picture. Future space exploration and lunar outpost. The lunar South Pole region is deemed as a compelling spot for future exploration missions and suitable for a lunar outpost. The permanently shadowed places on the moon could contain ice and other minerals, which will be vital resources for future explorers. A rendering of the Novosil lander for IM-1 mission is shown in this picture. Using Lunar Orbital Laser Altimeter, a device used by NASA to provide an accurate topographic model of the moon, scientists studied moon topography. Lunar showed that the South Pole at connecting ridge, which connects Shackleton to the crater Galaxy, contains sunlight for 92.27 to 95.65% of the time, based on altitude ranging from 2 meters above ground to 10 meters. Orion spacecraft moving towards the moon is shown in this picture. The lunar South Pole is a place where scientists can perform unique astronomical observations of radio waves under 30 MHz. The lunar South Pole has mountains and basins such as the south side of Malapert Mountain. Artist's concept of NASA's volatile imaging polar exploration rover is shown in this picture. For more information, contact Astronautics for Exploits. You've been watching and listening to Lunar South Pole, a priceless region for future space exploration and lunar outpost, presented by Dr. Anyanshola Ogundele, with the focus points Lunar South Pole, future space exploration and human outpost, Lunar South Pole resources, and Lunar South Pole geography. Thank you.